Forrest works actually at NPM Inc., which, as far as I have met, every single person, so far everyone I've met who works at NPM is brilliant, genius, super hacker, awesome people, and so that's an amazing sign. And I was chatting with a little bit about his talk, and I think that there's a decent chance he may blow your minds. So hold on to your chairs after you give him a hand.
Good morning, everybody. As he said, my name is Forrest Norvell. I am the very good developer in charge of the NPM command line interface, and that is, in fact, my official title. This is a code-heavy talk that focuses on Node, but there are some interesting pieces for the front-end developers among you towards the end, so I'll let you know when you can wake up. So, why did I make this weird thing with the long name? Well, before I worked at NPM, I worked for New Relic, and I was writing a monitoring tool for them. And I needed a way to trace transactions through web requests, and I needed to do that in such a way that I could pass information all the way through all of the asynchronous calls that happen in the process of handling one of these web requests. And it took me a number of tries to get it right. I tried to brute force it. I tried all kinds of clever stuff, including call stack manipulation and even source tree manipulation. And I just couldn't make it work because I didn't have access to a bunch of the code that I was working with, because I didn't know what you as developers were going to be running, and I needed to figure out how to get this stuff through there. So this is what I eventually came up with. And what you need is you need variables that are scoped across these many concurrent requests that are individual to that request. If you've done any threaded programming, you may be familiar with a concept known as Threadlocal storage. Threadlocal storage allows you to actually keep track of what's going on that thread, so you can have individual pieces of your application that are dealing with concurrent requests that have those things scoped only to that thread. Node's JavaScript is threadless. Some people like to talk about it as being single-threaded, but I find that to be somewhat more confusing than it is useful. I prefer to think about it as being a threadless environment from the JavaScript side of things. We use callbacks for all of this stuff instead. So why are some of these callbacks called continuations? Each async function gets passed a callback. When you read a file using the FS module in Node, you give it one of these callbacks. That callback is how processing is going to continue. It's how you do the next thing. And in fact, if you've used Express a lot, you know that Express actually explicitly calls that continuation next a lot of the time. So that callback is called a continuation because it's how you continue. And the style of asynchronous programming that Node uses is called continuation passing style. And one of the things that is sort of interesting about Node is that typically before Node, the continuation passing style was an artifact of the compilation step. Like the fact that we force everybody to do this by hand is actually a kind of a regression back to the Neolithic era in programming terms in some ways. The thing about this is that CLS is actually a lot easier to use than describe, so I'm going to kind of try to talk about it in terms of real Node apps. And this isn't actually from Gandhi. As far as anyone knows, this quote is actually attributed to a guy named Martin Mull, who was a comedian and musician in the 70s. So, you're writing an Express app. You've got a middleware that fetches a session. Don't worry too much about that being readable because I've focused in on the important part. This is the default solution for doing this inside Express apps. You just take some data, slap it on the side of the response. It can cause some strange stuff to happen in your own applications because you may have something that has errored out early, or you may have a cyclical data structure and you may pass that response off to a logger and your entire world explodes. And sometimes it takes you a while to figure out what's going on with that. And you can't do that when you're writing tooling. You cannot cause people's applications to explode. So that's kind of a no-go right there. You also have a root handler where you're going to grab this information and you're going to do stuff with it. The thing that's interesting about this works just fine. You can stick these things on these properties, but the things that you're sticking them on have to be visible to you. So if you have a database handler or some other code that is out of scope, then you aren't going to be able to see that thing and be able to use it. So this works okay, but it's brittle because of that need to have it in scope. And also, you're modifying objects you didn't create, which especially if you're trying to do anything generic or abstract and not coupled is just kind of a no-go. And it can also make it very hard to recover from early errors, which again, if you're trying to write tooling, you want to allow things to continue as far as they would have without you there. So now you want to send this data elsewhere. You're going to send it off to Redis or MongoDB or some sort of thing that's going to write some stuff out and maybe write something else to the file system. And you still want to be able to get at these pieces of state, but you can't because they're inaccessible to you. So like, how are you going to send back success? You can't get something back to the request once it goes off in this unless you pass one of these like other objects along, which is introducing a coupling point into your code. What happens when some of those pieces are from libraries that you don't have control over? You're just consumers of them. You aren't the people who are actually writing that code. I mean, there are workarounds for almost all of this. You can create closures around things. You can come up with ad hoc solutions, but that's not, again, going to work really well for a more complex, modular, like loosely coupled application. It's not going to work really well if you're trying to write stuff that's running at a lower level. So things are getting pretty complicated. There's a lot of moving parts in modern servers, especially if you're using more modern plugin-based tools like Happy, where everything's supposed to be broken down into like discrete little chunks. And there are interdependent concerns here. You may be wanting to do all kinds of things with that data, and you just aren't going to have access to them. And also, you still have to deal with the problem of concurrency. You can't use a little shared state module to keep track of this because it's going to constantly be getting stomped on as new requests come in. So I had this problem. This is pretty much exactly the problem statement for what I had to deal with at New Relic. I couldn't break your apps, and it needed to be lightweight, which means it couldn't introduce too much overhead, and it needed to be safe. So I built continuation local storage. And there's an asterisk there for a reason. This was a very complicated problem. I could not have solved it alone. And let's see, Tim Caswell, Creationix, helped me a lot with the initial prototype of getting all this stuff moving across the, moving around. Trevor Norris, I'll talk about the work that he did in a little bit. And Isaac Schluter, my boss, helped me out with this a bunch. And also Jacob Groundwater at New Relic helped me out a lot, figuring out some of the weird edge cases around this. A lot of people have participated in building this fairly simple thing. It creates namespaces that are global to a process. So you can see that create namespace thing at the top, and then down below somewhere you can see that you're getting a namespace. Those namespaces are global to a process, and the only reason they exist is because different applications need to be able to use CLS without stomping on each other. So they need to be able to set and get these values. And also you'll see that there is, let's see, you can't really see it here, but you need to run stuff inside CLS. You have to explicitly say this thing is going to be using this storage mechanism. And so there's a function that looks a lot like the domains API that allows you to basically say this code is now being run inside CLS. And then once you're inside that code, you just get and set values in the namespace, and they're there. It's kind of magic. It's got a lot of interesting uses that I'll talk about later. It just kind of works. I have to address the name. You can see that the name is continuation local storage, and now I put my NPM hat on for just a second. That name is like that for a reason. Domains have a terrible name. How many people here actually know what domains are for in Node? Yeah, there's very few of you. How many of you have actually used domains? Very few of you. I think those two facts are correlated. So continuation local storage is like Threadlocal storage, and it's not really that hard to type in 3 words periodically. This is true of more than just this. In general, when you're naming your apps, please use descriptive names. Like, discoverability is hands down the #1 problem inside NPM right now, and being clever is fun. And we've bike shedded all these other names for domains, like Hugs, which is Bryce Barrel's choice, or Guardians, which is Rick Waldron's, but like, be verbose. Thank you. I'm taking off my NPM hat now. So, how does continuation local storage work? Well, it's pretty simple. It's only about 150 lines of JavaScript, but that's because it's not actually doing any of the hard work. The hard work is being done by the Async Listener API. So, okay, how does the Async Listener API work? Well, it's pretty simple. It's only about 450 lines of JavaScript, and it's no big deal. It just monkey patches everything asynchronous inside Node core. That code is gnarly. It has defeated the attempts of pretty much everybody who's worked on it to completely understand it in total. The great part is you don't have to care. There are 2 versions of this API, one that's been under development in Node 0.11, and another one that is a polyfill that I maintained that I wrote with Tim Caswell. My polyfill doesn't track the latest version of Trevor's API. That's fine, because Trevor's API is probably going to be pulled from 0.12 because we need to bike shed it some more. It's hard to figure out what layer of abstraction this stuff needs to run at. And the Async Listener API was originally written explicitly to support this particular use case. So to give you a simple example of how async listener works, everybody likes long stack traces, right? Like, they should be probably in Node by default. It's really hard to figure out what's going wrong when you get an error like 16 things down the chain and you don't know what's going on. So here's Jacob Groundwater's stack up module. It's really simple. You run something that's going to blow up. Like, there's no non-existent method on that empty variable because it hasn't been initialized. So you get a pretty simple stack trace that shows you not just like the immediate cause of the error, but goes back to pretty much the beginning of the process to show you what chain of events led to that happening. And this is an important thing to understand because this helps you understand how CLS itself works. These long stack traces are short stack traces that have basically just been stapled together when you go across asynchronous boundaries. So as you go between ticks of the node event loop, that is an asynchronous boundary, and when you hand things off to read a file and it comes back off the file system, that's another asynchronous boundary. The async listener API basically says, hey, these things are going to happen, or these things have happened. Do you want to do something with that? So in the case of StackUp, what it does, it's like, oh, hey, the stack is going to be reset. Go ahead and grab this, or the stack has been reset. Go ahead and keep creating this long stack trace that we can dump in the case of an error. So full discussion of that API is completely out of scope of this discussion. The important thing to know is that there's a lower level API that you can build on to use this, and it's going through some more changes. Watch the discussion of tracing that's going to start happening soon and will continue after the release of Node 0.12. But the important part is this allows the CLS module itself to be relatively straightforward. So, what is CLS? It gets and sets values as if they were global, but scoped to each chain of asynchronous function calls. It's no more and no less than that. I find explaining this to people very hard because what it's doing is kind of slippery, but using it is very easy. The API is very simple. There are operations to create and get those namespaces, like I said before, and you can see a clear example here of running stuff inside a namespace, and then you just set and get properties. You can't mutate things directly because it has to do some ledger domain behind the scenes to fix everything up, but it's pretty straightforward. And if this API looks familiar to the 6 of you who raised your hands who are familiar with how domains work, it looks similar because it's based on them. And in fact, my original goal was to get CLS landed in Node Core, and that was actually Isaac's idea when he asked me to work on it. But Trevor was just like, no, 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 for reasons that I'll get into shortly. What is it useful for? Well, it's great for transaction tracing, which is what I built it for, so that's good. It's also good for passing data through complicated web apps with lots of structure. You know, again, if you have a loosely coupled plugin-based web service architecture, you need a way to get stuff from point A to point B without necessarily being able to pass stuff all the way in between. It's great for doing request-specific logging, and it's great for working with third-party async code that you may want to get stuff through without really understanding what's going on in there. There are plugins right now for use with Express, Restify, and Happy. People write them when they have needs. The plugins are fairly easy to write, so please write more. So remember when I said that this patches everything asynchronous in Node Core? There are a bunch of edge cases, and the most troublesome things of support are connection pools and pipelines, because those reset the call stack in very specific ways, and they tend to bundle requests up and then deal with a bunch of responses at once, so you have to shim them. So sometimes you can use shims. The two big examples that I know of are if you're using the Node Redis driver, or you're using Node MongoDB, or you're using a bunch of those other drivers, you need that to deal with those connection pools and pipelines, and I'm happy to go into nearly infinite detail on that with you after the talk, because it gets very technical and I have to get kind of salty when I talk about the quality of some of the driver code. The other big issue is promises libraries. Because of how promises A+ promises work, they always reset the call stack as a byproduct of how they work. And sometimes that just works, but sometimes when you combine them, especially with connection pools, you need to do a little shimming. I need to write a Bluebird plugin because a lot of people use Bluebird. Bluebird is at least as clever in terms of doing weird, bad JavaScript tricks as CLS is itself, so getting it to work properly has proved to be sort of a challenge. Sometimes, though, shims just aren't going to do the job, and you have to bind your callbacks to namespaces explicitly. This is just a kind of made-up example of a non-kosher, literally, lookup method with a database where you have something that you need to deal with. And there is if you don't find any meat, you don't get any ham. So this is the important part. You have to use the namespace stopbind method to make sure that the state is going to make it through to the far side of the asynchronous call. It's pretty straightforward. It breaks in pretty obvious ways, but this is something that it's easy to overlook in the documentation. So if you're giving it a shot and you see your state getting lost, you may need to go look for a call to a database or something where you need to wrap the call back up inside the namespace. And event emitters, oh God, event emitters, they are so terrible about this stuff. And the reason they're terrible is because event emitters are also the basis for streams. So if you have a stream where you want to make sure that the handlers for that stream are within the scope of the namespace, you need to make sure that you use the bind emitter method. That actually uses another module called emitter listener that's a lot like the async listener API. And if you are really into seeing like super gnarly workarounds for strange design misfeatures inside Node Core, give the source to that a look. I doubt many of you are as masochistic as I am, but like there is just some stuff that will, like I look at it now and I'm like, what is going on here? Why do I have to do this? Why is the world so terrible? But again, if you're dealing with that, especially if you're dealing with request and response objects, this is very similar again to domains. You just need to make sure that you bind that emitter onto the namespace so that the handlers will be within the scope of that. So, like I said, because connections and pipelines reset the stack their own special way, event emitters are very similar. The asynchronous call chain can't be fixed up automatically. It needs you as a developer to tell it, hey, this particular event emitter needs to be bound to this particular namespace. Thinking about event emitters is hard. We tend to think of them as being asynchronous, but they're actually a synchronous thing connecting to asynchronous things. And for more details on that, go back and review Nick Niemeyer's talk yesterday. New Relic synergy, it's great. All right, so let's talk about the consequences of this thing for a while. It was built to solve production problems, but there is no way to avoid certain trade-offs. And this is, in fact, why CLS is not in Node Core. Trevor Norris is sort of obsessive about performance. That's his particular spiritual genius. But he took one look at that, and he's like, no, this is not landing in Node Core. Domains are bad enough. We can't have another performance sync like this in Node Core. So let's talk about that. The CPU overhead of CLS when it's in use can be relatively large. That it looks bad. Like when Jacob did performance testing on this back in January, I think we saw it was like, I don't know, 800 times overhead. But that was when you're in a tight computational loop. As soon as you add any kind of I/O, and that's what we're using Node for, I mean, it's practically defined as a thing for doing fast evented I/O in JavaScript, it disappears below the noise floor. There's no statistically significant CPU overhead. Memory, kind of more of an issue, but again, it's really dependent on the particular details of your program. And the other thing is it does not actually change the behavior of your program otherwise. It's basically transparent. It's sort of magic. And that's because that is exactly what we needed it to be for the purposes of New Relic. So who's using this thing? Well, the good news is this is extremely battle-tested code because every customer of New Relic who is running New Relic for Node is running CLS in production whenever they're running New Relic in production. So we've gotten a lot of feedback. There have been surprisingly few bugs in it. And it's actually gotten, I'm feeling pretty good about the robustness of the library. There's also a small but mostly satisfied community of other users, and I think it's worth talking about this for a sec because they came to me. Like, I haven't really pushed this thing. It's kind of like I've kind of spent a bunch of time talking about it. It's hard to explain. It's hard to understand on some level, but it fits a need for a certain class of developer. And so there are people out there who are using it, mostly who have figured it out on their own. So if this looks like something that might solve a problem for you, talk to me. If you want to get an experience of somebody who has used this on their own, who doesn't like have a protective need to protect their baby, find Blaine Bublitz, because I know he's used it for a bunch of stuff. And Blaine is not going to give you a filtered opinion about anything, really. So there are people out there who are actually using this. But if you don't want to use CLS, CLS is not the only thing trying to solve this kind of problem. And hey, this is where the browser people need to wake up. So if you like browsers, there's Angular's Zone.js. It's part of the Angular distribution. And it turns out this Bryant Fjord guy is actually pretty good at JavaScript. And so it basically does the same thing. It's actually a simpler API in some ways. It's got to solve a different set of problems because it's something that runs inside the browser, and that means it has to run in multiple JavaScript runtimes. But it's pretty great. It works. And it's another tool that you can use if you have complicated single-page apps. You may want to be able to, and you're doing a lot of XML HTTP request stuff, you may want to have something like this to stitch everything together without doing all kinds of gross closure creation and threading of state. If you only want error monitoring, I do feel duty-bound to say that domains are out there. Some of you may have been to my domains workshop at NodeConf 2013. They're not perfect. I like to describe them as an interesting failure now, but they are part of Node Core. You can use them today. They're a great tool for error handling. I want to talk about them here because people have tried to use them to do something like CLS, and it turns out the needs of error handling and the needs of state propagation are pretty right-angly, and it gets kind of gross after a while. So this other thing exists. If you want to try to make it work in domains, I'm not going to stop you, but you probably don't want to do that. And if you really want to get out into the bleeding edge, Bert Belder, one of the developers of both Node and libuv, one of the big heavyweights on Node Core, has created a whole thing called zones for Node. So there's Angular zones and there's those other zones. But like this thing is a combination of a control flow library. It will automatically clean up after errors, which is sort of like the magic dragon to chase in the Node world for like systems level programmers, because you can't really combine like changing changing stuff and also having functional style programming where you can automatically recover from errors. And it doesn't really do state management, but it's pretty interesting because you get a lot of that state management stuff for free when you're using a promise-like API. And in the future, there's probably going to be some dynamic tracing inside Node itself with a JavaScript API. But like I said, that discussion is just beginning now. And if it's something that if you're interested in system-level monitoring or instrumentation, you should probably get involved in. And there will be more going on Twitter and on various repos about that very soon. So what's next for CLS? Well, the good news is I don't think there's really a whole lot left to do except to simplify it. The async listener API isn't done yet. I need to add shims for both MongoDB and Bluebird. I think that's kind of the base thing. I want to do a new major version of it that has better support for more of these things that are kind of edge cases. I want to make it work more automatically because right now you have to do some of the shimming yourself. I want to make that transparent. And also the documentation was originally written in the style of Node Core's documentation, and we could probably have 2 or 3 talks just on the topic of Node's documentation and how tragic it is all on our own. But I want to rewrite these docs to be more concept-oriented and to try and get some of the stuff across so that it's easier to work with and there's more. And if you want to help me out with that, that would be fabulous. Working on NPM does not leave me much time for having a life, much less working on my other open source projects. So patches welcome. I will be doing work on that probably before the end of the summer because I would like to actually get CLS done. Like, I have no grand empire dreams for this. Like, it's useful for a certain class of users. It might be useful for you. Play with it, give it a shot. But I don't have any particular desire to like change the world with this. It's just a useful tool for a very specific use case. And with that, thanks. Good luck figuring this out. Find me if you have questions.